Good morning. The Subcommittee on Space and Aeronautics will come to order. Without objection, the Chair is authorized to declare recess of the Subcommittee at any time. Welcome to today's hearing, From Detection to Deflection, Evaluating NASA's Planetary Defense Strategy. I recognize myself now for 5 minutes for an opening statement. First, I want to welcome everyone to the Subcommittee hearing this morning. Thank you for joining us. This is a hearing focused on a very important topic, NASA's role in planetary defense and the detection of near-Earth objects, commonly known as NEOs. While not as high profile as other NASA missions, the planetary defense is one of the most important research centers that basically this was the highest priority of American citizens. The fear that is somehow, some way, our planet could be under duress due to asteroids or other objects that could hit the Earth. And in fact, a lot of the popular movies have been based on it, whether it be Armageddon, Deep Impact, and of course my favorite from 1980s, Thundar the Barbarian. So these are all risks that we face in a very serious way. And of course, the last couple of years, this has come to our attention with the NASA-funded ground-based telescope discovered that there was a near-Earth asteroid that was designated as 2024 YR, and initial estimates had it as high as a 3% chance of striking the Earth. Fortunately, subsequent observations and analysis have lowered that impact to less than 1/100th of 1%, but this is still a legitimate concern, and that's why we're here today. This isn't the first time we've made a discovery like this. Back in 2004, NASA identified an asteroid named Apophis and found that it was within roughly 20,000 miles of Earth in 2029, less than one-tenth of the distance to the Moon. This process highlights NASA's critical role in planetary defense. The 2005 NASA Authorization Act directed NASA to detect, track, catalog, characterize the physical characteristics of an estimated 90% of NEOs by 2020. While NASA has made progress toward this objective, much work remains. As of last September, NASA estimated it had only identified 44% of the estimated population of NEOs larger than 140 meters, less than half of its goal, but help is on the way. The NEO survey mission, the first spacecraft explicitly built to detect near-Earth asteroids and comets, is scheduled to launch by 2028. NEO survey offers an important capability as it uses infrared detectors to detect objects that would otherwise be difficult to find due to the glare of sunlight. I look forward to learning more about this key mission during today's hearing. However, NASA's efforts to extend beyond detection and identify NEOs. In 2021, NASA launched the Double Asteroid Redirection Test, also known as DART, a mission to research 2 asteroids that would fly in Earth's vicinity. Nearly 10 months later, DART successfully impacted the smaller asteroid, altering its orbit around the large one and providing key data. This mission demonstrated the feasibility of redirecting a NEO and proved out many technologies that could be pivotal in future initiatives. NASA's work in planetary defense has long enjoyed bipartisan support on the SST committee, and I'm optimistic that this will continue. I'm eager to hear updates on NASA's progress towards achieving this congressionally mandated mission. I also welcome the opportunity to hear about development of NEO Surveyor and the ongoing work of the Minor Planet Center in cataloging these objects. Thank you to each of the witnesses for being here today, and we look forward to a very productive discussion. And before we move on, I'd like to request unanimous consent to submit a letter from the Planetary Society for the record. Without objection, so ordered. And with that, of course, I want to recognize our outstanding ranking member, the representative from North Carolina, for her opening statement. And you are recognized, Ms. Fushi.
Good morning, and thank you, Mr. Chairman, for holding today's hearing. I want to extend a warm welcome to our expert witnesses. Thank you all for being here. Under most circumstances, this hearing would be a natural continuation of the committee's periodic review and oversight of NASA's near-Earth object and planetary defense activities, activities that Congress, led by this committee, directed in law. Near-Earth objects, or NEOs, pose real, though infrequent, threats. We had a taste of a NEO threat in late 2024 and early 2025 with the detection of the 2024 YR4 asteroid that was initially estimated to have more than 1% chance of impacting Earth in 2032. Thankfully, NEO and planetary defense efforts, both in the U.S. and internationally, were in place to analyze and assess the threat, and the projection was later reduced to near zero. Today's circumstances, however, are far from ordinary. The Trump administration's recently released skinny FY 2026 budget request proposes a $6 billion, or 24% cut to NASA. NASA's Science Mission Directorate, which oversees and funds NASA's NEO and planetary defense activities being discussed today, would see a staggering 47% cut from the FY 2025 levels under the full-year continuing resolution. While we are still awaiting the more detailed budget proposal in the congressional justification, one thing is clear. This budget, if enacted, would strip away NASA's storied leadership, disrupt decades of progress in U.S. space exploration, and cripple the agency's ability to pursue bold and ambitious goals going forward. That would be a sad and hollow future for our civil space program. It would be an embarrassing recipe for failure, and one we must wholeheartedly reject. It also risks jeopardizing U.S. global leadership across the science and technology frontier and in emerging technologies like artificial intelligence, with drastic cuts being proposed across the federal science ecosystem. Since taking office, the Trump administration has canceled nearly $20 million in NSF research grants to my state. These federal cuts also threaten the livelihoods of our local communities and are leading already to job losses in my district, North Carolina's 4th. The depths of losses for NASA would be far-reaching, impacting everything from support to the International Space Station, to aeronautics research and development, which advances aerospace and aviation, a sector with historically positive trade balance, and so much more. NASA's Earth Science Division would take a $1 billion hit, threatening, for example, the continued Earth observations and information that can help our farmers estimate crop yields and assist emergency responders in preparing for and responding to natural disasters. The tornadoes, droughts, flooding, wildfires, and hurricanes that ravage communities like recently in my home state of North Carolina are neither red nor blue. However, this administration has chosen to kneecap our ability to understand, predict, and respond to these devastating and expensive disasters. For example, hundreds of scientists slated to work on the statutorily directed National Clients Assessment have been dismissed, and a NASA support contract for the U.S. Global Change Research Program was canceled. These actions are unrecognizable in an agency that has been the gold standard and world leader in space and has achieved historic results characteristic of our great nation. If enacted, the Trump administration's skinny budget proposal risks putting NASA on a path to irrelevance. It threatens our economic and national security, surrenders U.S. leadership in space to our adversaries, and jeopardizes our competitiveness and standing on the world stage. That's a strategic posture I simply cannot accept. There is only one choice before us. We must preserve NASA's ability to inspire the next generation and to lead in all of its science divisions, aeronautics, low Earth orbit, and to the moon and beyond. We can only do so if we work together to provide NASA with the necessary direction and resources, and I commit to doing just that. I look forward to working with you, Mr. Chairman, and my colleagues on the committee to continue our bipartisan legacy of ensuring a strong, stable, and bold future for NASA. Thank you, and I yield back.
Thank you, Ranking Member Fushi. Since Chairman Babin is not here, I would like to recognize our ranking member of the full committee for a statement. You recognize Congresswoman Lofgren.
Thank you very much. You know, during my tenure as a member of the Science Committee, I've sat through occasional hearings the committees held on near-Earth objects, or NEOs, as we call them, risks that they could impact Earth, and NASA's progress in complying with statutory direction to detect, track, and characterize NEOs. Planetary defense, as with many of the challenges that our S&T capabilities help address, is a multidisciplinary interagency and international endeavor. That's made clear in the 2023 National Science and Technology Council's National Preparedness Strategy and Action Plan for Near-Earth Object Hazards and Planetary Defense, which was updated from the 2018 Strategy and Action Plan. Now, while NASA is designated as the lead in many of the plan's actions, other agencies, including NSF, Department of Energy, Department of Homeland Security, FEMA, and Department of State are also named to lead on planetary defense actions in the Strategy and Action Plan. For example, NSF is to lead on an interagency assessment to explore coordinated development of existing and future deep space radar facilities and how they may be used for planetary defense. DOE is named to lead on the study of circumstances when only use of a nuclear explosive device would provide the necessary capability to mitigate an impending NEO impact. DHS's FEMA would lead on an impact risk data pipeline to inform decision makers on results from integrated modeling of potential impact threats. The Department of State would lead on engaging and informing foreign governments of the need for a comprehensive and coordinated approach to preparing for a NEO event. It's clear that planetary defense leverages many of our federal S&T agencies. Now, whether that federal agency continues, whether that expertise continues, I think is now in question. Probationary employee layoffs, deferred resignations, and widespread planned rifts are creating a brain drain. Moreover, under the Trump administration's fiscal year 2026 so-called skinny budget proposal, here's what would be cut. As the ranking member of the subcommittee has said, NASA would see a 24% cut, NSF a 55% cut, DOE a 9% cut with much steeper cuts to DOE's Office of Science. FEMA may not even exist. The Department of State would be cut 47%. Will anyone be home to answer the call if a NEO were found to be on a trajectory headed toward Earth? Would any remaining federal workers have the necessary skills or know-how to act? I don't want to go on, but I think the message is clear. I hope this committee, as we've done on a bipartisan basis on countless issues over the decades, will roll up our sleeves together to reverse the dismantling of our science enterprise and reject the proposed cuts that pose long-term harm to this country. We owe it to Americans and to our grandchildren to ensure a safe, secure, and bright future full of opportunities and hard work for all. Thank you, Mr. Chairman, and I yield back.
Thank you, Ranking Member Lofgren. Now we, of course, our chairman has arrived. Great to see Mr. Chairman. I now recognize the chairman of our full committee, Dr. Babin, for his remarks.
Thank you, Mr. Chairman. I appreciate it. Good morning. We have an exciting hearing today on NASA's efforts to save the world, literally. I also want to thank our witnesses that are here today. We're looking forward to hearing what you all have to say. But NASA's Planetary Defense Coordination Office, or PDCO, leads the United States' mission to safeguard the Earth from near-Earth objects, or NEOs, asteroids and comets that approach our planet. While most NEOs are harmless, those exceeding a certain size could cause catastrophic, even extinction-level impacts. U.S. efforts to detect NEOs began in the 1990s, but a major initiative was passed as part of the 2005 NASA Authorization Act. The George E. Brown, Jr. Near-Earth Object Survey Act directed NASA to detect, track, and catalog 90% of the NEOs larger than 140 meters in diameter within 15 years. At that size, an NEO Earth impact could cause significant regional destruction. Nearly 20 years after the Act's passage, only 44% of the estimated NEOs larger than 140 meters have been identified. Despite being 5 years past the original deadline, many potentially hazardous asteroids have yet to be found. The world was starkly reminded of the importance of planetary defense in 2013 when a house-sized meteor exploded over Russia. The blast released energy equivalent to about 440 kilotons of TNT, more than 30 times the force of the Hiroshima bomb, shattering windows, injuring thousands, and causing millions of dollars in property damage in Russia. Because the asteroid approached from the direction of the sun, it was undetectable by ground-based telescopes and went untracked. The resulting explosion caught the world entirely by surprise. In the aftermath, this committee held a series of hearings to examine the risk posed by NEOs and assess NASA's progress under the George E. Brown Jr. Act. Given recent events, we believe it's timely to continue those efforts today. At the end of last year, NASA detected a new NEO that, at one point, had a 3.1% chance of impacting Earth in 2032. Subsequent observations have since lowered that risk well below 1%. Nevertheless, NASA's ability to detect the asteroid with 7 years of advance warning highlights the important progress in NEO monitoring. NASA has also made significant advances in testing mitigation technologies. The 2022 agency's Double Asteroid Redirection Test, or DART mission, if you all will recall, successfully collided with a small asteroid named Dimorphos, providing valuable data and proving that kinetic impact mitigation, or crashing a spacecraft into an asteroid, can effectively alter an NEO's trajectory. Finally, one of the most critical missions for planetary defense is NASA's upcoming NEO Surveyor mission, the first space telescope dedicated solely to planetary defense. Scheduled to launch in the fall of 2027, NEO Surveyor will enhance detection of asteroids regardless of their darkness or proximity to the sun, helping to close current detection gaps and meet the goals set by the Brown Act. Today, we will revisit NASA's approach to planetary defense, from discovering new NEOs to planning for potential interventions. We'll also hear about the process for maintaining the NEO catalog, developing models and simulations, and calculating the likely impact consequences. Finally, we'll discuss strategies for deflecting or disrupting a hazardous asteroid and the anticipated outcomes of such actions. Protecting our planet from threatening asteroids and comets must be a top priority for NASA, and I look very much forward to hearing from our witnesses today. Thank you, Mr. Chairman. I yield back.
Thank you, Mr. Chairman, for your thoughtful word. At this point, we'd like to introduce our witnesses. Our first witness today is Dr. Nicola Fox, who serves as the Associate Administrator for NASA's Science Mission Directorate. Second is Professor Amy Mainzer from the Department of Earth, Planetary, and Space Sciences at the University of California at Los Angeles. And our third witness is Dr. Matthew Payne, who serves as the Director of Smithsonian Astrophysical Observatory's Minor Planet Center. I'd like to thank each of you for joining us today. And I now recognize Dr. Fox for 5 minutes to present their testimony, which will begin with a brief video, as I understand it, highlighting NASA's important role in planetary defense. Thank you for being here.
Potentially hazardous asteroids can show up anywhere in the night sky at any time. Oh, this might be something. Oh, you guys, look at that. Right now, it is absolutely a potentially hazardous object. If you guys were going to be here for a discovery, a PHA is definitely what you want. Yeah. This is a big rock, yeah.
What would an asteroid that is a kilometer in diameter, what would it do if it hit the Earth?
That is likely to end human civilization.
Those objects are big enough to cause what we would call truly global devastation, meaning that they could cause global extinction events. The good news is that we found more than about 95% of them. When we get down to smaller objects, things that are larger than, let's say, about 100 meters across or so, now the picture's not so rosy.
Today, we do not have a complete inventory of all the possible impactors.
there's almost certainly a decent-sized asteroid out there that is going to pose an impact threat to the planet. We're just trying to find it right now.
And that is something that NASA and the worldwide planetary defense community has been endeavoring to do.
There's a huge community of astronomers that start observing it.
From all around the globe.
Finding asteroids, tracking them, calculating their orbits.
Asteroids don't care about international boundaries.
It doesn't matter where the asteroid impacts. It affects, the entire humanity. In fact, anything alive on the Earth.
I really like that I'm protecting the planet.
Let's say we do find something that poses an impact threat to Earth. What next?
The day is coming when Earth will get impacted.
The dinosaurs went extinct because they didn't have a space program. We do have one.
We can. So why stop there?
We know it will happen. We just don't know when it will happen.
Thank you so much for letting us show that. I have to say I'm very calm now the video actually worked. That was the thing I was the most worried about. Good morning, everybody. Chairman Herodopoulos, Ranking Member Fushi, Chairman Babin, and Ranking Member Lofgren, and all of the distinguished members of the subcommittee. It's a pleasure to see you so soon after I was just here. So thank you so much for letting us show the video. As you saw in that quick video, that's the trailer for our newly released Planetary Defenders documentary, and it certainly will take you to the frontiers of asteroid detection, really in action with NASA's global team of planetary defenders. And as you can see, NASA is at the forefront of maturing asteroid detection techniques and ensuring Earth's safety from these cosmic threats. In December of 2024, as many of you have mentioned, NASA discovered an asteroid about the size of a 15-story building, which we called 2024 YR4, and that was discovered using the Atlas Sky Survey system in Chile. This asteroid continued to be monitored by NASA and the worldwide planetary defense community, and it was determined to have that 1% chance of Earth impact on December 22nd, 2032. Too many twos. While a 1% chance may have seemed low, it is rare for an object of this size to actually reach that level of probability. As NASA publicly updated the YR4's impact probability, we did that based on our understanding of evolving data, and we let the world see the science of planetary defense in action. By late February of this year, 2025, we'd collected enough data to actually rule out the significant impact threat for Earth for the foreseeable future, although the moon is still a little bit worried. The 2024 YR4 event underscores NASA's critical role in defending the planet from asteroid impacts using these early detection systems, also using advanced modeling and the international coordination, which is so important. NASA's been involved in finding and better understanding near-Earth objects, or NEOs, since 1998, and to date, the NASA-funded telescopes have been responsible for finding 96% of all NEO discoveries. Thanks to NASA's Planetary Defense Program, we do not know of any sizable object that has a significant risk of impacting Earth in the next 100 years. However, there are a lot more to be found. And that is why the agency is currently building the NEO Surveyor mission, a little model of it here for you. And it's confirmed to be launched by June of 2028, although we are ahead of schedule and hoping to get it up much earlier. It will be the world's first space telescope dedicated specifically to hazard asteroid detection. The mission will improve NASA's ability to discover and then to define the sizes and the orbits of the NEOs to understand the hazard they actually pose to us here at Earth. Finding those potentially hazardous asteroids remains a top priority for NASA's Planetary Defense Program. And our Planetary Defense Coordination, which of course is within the Science Mission Directorate, is the primary U.S. government entity responsible for finding, tracking, and characterizing potentially hazardous NEOs. The office not only collaborates with other federal agencies and international partners to guide the planning in the preparation for an actual impact threat, but it also works to bring asteroid deflection and mitigation strategies to fruition. In 2022, NASA successfully demonstrated one method of the asteroid deflection using the kinetic impact of spacecraft with the double asteroid redirection test, or DART, as many of you have mentioned. And it intentionally crashed into an asteroid to see if we could change the orbital path in space. It was really the first time that humanity had moved a celestial body in space, and it proved that an asteroid impact as a natural disaster could have humans' intervention, and it could be prevented with enough warning time. Continued U.S. leadership through NASA ensures the world remains prepared to detect hazardous objects early, understand their nature, and develop strategies to mitigate potential threats, turning what was once an unpredictable natural disaster into a potentially manageable and preventable risk. As you heard at the end of the video, an asteroid impact did wipe out the dinosaurs, but the dinosaurs didn't have a space program, and they didn't have NASA's Planetary Defense Coordination Office. We do. And so I look forward to NASA continuing to discover and innovate for the benefit and the safety of all, and I look forward to taking your questions today. Thank you so much.
Thank you, Dr. Fox. I now recognize Professor Mainzer for 5 minutes to present her testimony. You're recognized.
Thank you so much, Chairman Herodopoulos, and thank you, Ranking Member Fouché, for inviting me here, and to all the members of the committee for having me here to talk to you about this important topic. I'm Dr. Amy Mainzer. I'm a professor of planetary science at UCLA, and I'm also the lead of NASA's Near-Earth Object Surveyor mission, which you've been hearing about. Now, every day, about 100 tons of material from asteroids and comets rains down on our Earth, but we mostly see it as tiny little pieces of sand grain-sized material that appear as shooting stars to us. They're harmless, perfectly harmless. But we know from looking at craters on the moon and recent experience here on Earth that this isn't always the case. Sometimes asteroids are much more of a hazard. I've actually got 3 meteorites here from UCLA's world-class meteorite collection. This is a piece of Canyon Diablo. This was a fragment of a 50-meter sized asteroid that impacted the desert in Arizona about 50,000 years ago. And it was capable of blowing a mile-wide crater in the ground that is still there today. You can see it's quite heavy, solid iron. This object is called Allende. This is a very famous meteorite that represents the dark material that makes up a significant fraction of the near-Earth object population. And this is important because since it's so optically dark, it's made of carbon-rich material, this is hard to see. It's just dark. So this represents an important fraction of the population that we need to find. And finally, I have a piece here from the meteor that exploded over Chelyabinsk, Russia in 2013. This object was no bigger than the room that we're sitting in today, and yet it was capable of sending about 1,600 people to the hospital, mostly from flying broken glass. So these are not the objects that we need to really worry about because these are small. This is, in particular, a very tiny object, not capable of making a huge crater in the ground, but there are other objects out there that are much larger that we really need to pay careful attention to. And in particular, if they are even a little bit larger than the ones that I've shown you here today, it's not just an airburst that knocks out some windows or creates a crater in the ground that is, relatively small. Now we're talking about impacts that can actually wipe out an entire region, lay waste to a country, or devastate the planet. And this is something that we can do something about, actually. This is a natural disaster that is 100% preventable if we do our homework, if we take the time and trouble to do it. If we can find these objects far enough in advance, we can actually deliberately alter their orbits, but we need time to be able to do that. NASA has already demonstrated through its DART mission that we can deliberately change the orbit of an asteroid, but only if we know it is there and we have enough time to plan an effective mitigation strategy. So to that end, we are building the Near-Earth Object Surveyor Mission Telescope, and the objective is to create a space telescope that will sense the asteroids using infrared technology, heat-sensitive technology. The U.S. leads the world in building these kinds of detectors, and they are capable of spotting objects regardless of whether they are lighter colored or dark, like this one here, like Allende. In addition to being able to spot the objects, we can also measure their sizes, and that will tell us whether or not it is likely to be a relatively harmless object or something that is capable of causing really severe devastation on the ground. And even something the size of Canyon Diablo, if this were to hit a city, it would level it instantly, pretty much. So that is why we are building NeoSurveyor. The mission is under construction right now. All major elements of the payload in the spacecraft are being constructed. It's being built and managed at JPL with major portions of payload testing happening at Space Dynamics Lab in Utah. We've just completed a major thermal test at Johnson Space Center in Texas. We'll be launching out of Kennedy Space Center in Florida on a Falcon 9 rocket in late 2027. And as my colleagues have noted, this is a natural disaster that we can absolutely prevent if we can take the time to go just do our homework. And as noted, the dinosaurs did not have a national space program, but we do, and we are working on doing something about this problem. So thank you for taking the time to hear me today.
Thank you, Professor. And now I recognize Dr. Payne for 5 minutes to present his testimony. You're recognized, sir.
Thank you. Chairman Babin, Ranking Member Lofgren, Chairman Heraldopoulos, Ranking Member Foushee, and distinguished members of the subcommittee, thank you for your support of planetary defense and for the opportunity to speak with you today about the Smithsonian Astrophysical Observatory's national and global efforts to defend our home planet from the threat of near-Earth objects. I appear before you as the Director of the Minor Planet Center, whose global mandate and reach places us at the heart of planetary defense. So the Minor Planet Center...
Dr. Payne, would you mind moving your microphone closer, make sure it's on as well?
Can you hear me?
Much better.
I apologize. Okay. So the Minor Planet Center has been operated by the Smithsonian Astrophysical Observatory since 1978 and is the internationally recognized authority for the collection, processing, and dissemination of observational data on the positions of small bodies in the solar system. So this includes comets, natural satellites, and asteroids of all kinds, including those whose orbit might lead to a collision with the Earth. So the Minor Planet Center is sanctioned by the International Astronomical Union, and we serve as the world's official clearinghouse for asteroid tracking. Our center is both funded by and works closely with our colleagues at NASA's Planetary Defense Coordination Office, and the Minor Planet Center serves as a critical node in the International Asteroid Warning Network. So each year we process more than 50 million observations, submitted from over 2,500 observatories across 80 different countries. Among these data are the critical early detections of near-Earth objects, some of which may pose potential hazards to the Earth. We track the orbits of all 38,000 currently known NEOs, and including the more than 2,500 potentially hazardous ones. And an impact by any one of those would be devastating. So with these stakes in mind, identifying these threats requires the Minor Planet Center to combine technical expertise, highly complex modeling, with critically needed human judgment. Our systems must rapidly distinguish new objects from known ones, prioritize those that pose potential risks, and publish the orbital data so that they can be used by researchers, planetary defense planners, and decision makers worldwide. As the keystone of global coordination in this arena, the Minor Planet Center is central to the first and arguably most important component of planetary defense, i.e. the detection and tracking. Our near-Earth object data set enables rapid follow-up by astronomers worldwide, provides refined orbital paths, and ensures timely assessments of impact risk. One recent example that has been mentioned a couple of times is the near-Earth object 2024 YR4, which was potentially flagged as an impactor with a small probability of collision in 2032. Had it hit the Earth, it would have done so with the energy equivalent to an 8 megaton bomb, so that would have been enough to kill millions if it impacted near a population center. Thanks to continued observations by astronomers worldwide and the swift coordination and sharing of that global data via the Minor Planet Center, its orbit could be calculated more precisely, and that impact threat was ruled out within a few weeks. However, that scenario served as a critical reminder that early detection offers our best and possibly only opportunity to mount mitigation efforts, especially given the years of lead time that are likely required to prepare that response. I'll note that beyond natural objects, the Minor Planet Center also plays a supporting role in broader space domain awareness. We regularly filter out observations of artificial satellites and pass the data to our colleagues at the US Space Force to contribute to their tracking of orbital assets and debris. And this capability to distinguish between natural and artificial objects is important for rapid identification of hazardous objects and is growing increasingly critical in an era of growing orbital congestion. But we face some real challenges. The Vera Rubin Observatory and NASA's NeoSurveyor mission, when they come online, then they will send the Minor Planet Center 10 times more data than it currently receives from all other sources combined. So we've made, and we must continue to make, improvements in our hardware, software, and processes to ensure that the planetary defense community is able to utilize this wealth of new data to safeguard us all. And one example of this is our development of AI techniques to improve the speed and accuracy with which we can identify NEOs within the stream of data sent to us. And we'll continue to work with our colleagues at the Smithsonian's Astro AI Center on further applications of AI in planetary defense, and in particular to the processing of data from the NEO Surveyor mission. And we're also exploring some international collaborations, particularly with the European Space Agency, to see whether we can support 24/7 operations and some shared analytic tools and resources. Chairman and members, planetary defense is not a theoretical exercise, it's a practical, ongoing, and globally shared responsibility. And the Minor Planet Center is not just a data repository, it's a global nexus of asteroid tracking. And the Smithsonian Astrophysical Observatory and the Minor Planet Center are proud of our work and global leadership in safety, diplomacy, and preparedness. Thank you for your attention and your continued support for this critical mission. I look forward to your questions.
Thank you, Dr. Payne. With the witnesses with their testimony complete, I now recognize myself for 5 minutes for a few questions, if you don't mind. For Dr. Fox first, we've all heard about the Y4 scare just recently, and of course we're all pleased that the number went down from approximately 3% to less than, or almost zero. But that being said, what's the first thing that you all do when you feel like that an object like this is a potential threat? If you could walk us through those steps, that'd be great.
Yes, certainly. We actually spent time putting together the process so that we have this like a notification process. So when that first observation is made, as you heard, it goes into our Minor Planets Center. They actually sort of look and say, is it real? Yes, no. If it's real, then we start doing, we actually put out an alert. We use our worldwide international network to take as many observations of it as we can. The most important thing, the trajectory. The first thing to do is get that trajectory down. It does take a little time because this is a very small object. It's moving very slowly, and so it can take a number of days to actually sort of get enough. But it gives us enough to start saying, okay, it's within the 1% window. If you imagine you've got a pretty big swath, and the Earth is anywhere in that to give it that 1%. We can, at that 1% threshold, we actually kicked off the notification process. This was the first time we'd ever done it. So it sort of rang out some of the, the kinks, and we got it going. The first thing we did, we informed all of the agencies in the U.S., all of our other government agencies. The acting administrator, Janet Petro, chaired a sort of meeting where we explained, because everyone was new in their positions, we explained the process, what was going to happen, they were going to get this information and what it meant. We also then, through the international, we kicked out the sort of international network. We put out a lot of information into the media and explained what was happening. Then we continued to take the observations. As you noted, it went up to 3.1%. We continued over many nights to take these observations. We also had time on the James Webb Space Telescope when it crossed into the field of view to allow us to actually do a much better job of characterizing the size of it. As we continue to take more observations, and in fact, before it actually got into the James Webb field of view, we'd actually managed to do more trajectory work, and then determined that the trajectory had now sort of shrunk, moved, and the Earth was on the other side of it. Although, as I noted, there is still a 1% chance that it could impact the moon. At that point, we sort of, we notified everybody that it was back down to almost zero. Had it actually gone above 10%, then there's a second notification that we would do, and then we would actually kick off, a study into what could we do about it if we needed to have a mitigation technique.
And as a follow-up, and if other witnesses want to interject as well, that'd be welcome. I think the issue, as our chairman mentioned, 2032 is the potential time period.
Correct.
How much lead time do we have on something like that? And then the second part of that question is, if we identified a larger threat, how long would it take us to ramp up the interceptor in order to hopefully divert this potential chaotic experience?
So we have a number of different techniques that we could use to actually deal with the asteroid, and the longer we have, the easier it is to do it. I will note with YR4, it would have come back, it will come back, be observable in 2028, which would have given us another opportunity. The idea would have been to launch something to actually go look at it, study it, and work out, really understand the composition, which is important for the impact. But the longer time we have, the better job we can do with doing that. But we do have many studies, mission concept studies that are funded by NASA looking at different ways. The DART mission, as you alluded to, is one of the easiest ways. It's a kinetic impactor. You send a large spacecraft, you hit it hard, and it moves. But there are other ways of doing it as well.
And is that a common time period? I mean, we'll have 8 years at a minimum. Are there situations where that could be a much shorter period of time, given the velocities, et cetera?
It really depends where it is in the sky. As the Chairman Babin noted, the asteroid that came and impacted Russia came directly from the sun, and it's really impossible to see that. Has that changed? If that happened, where we can detect it from the sun now? We still couldn't detect it if it was coming directly from the sun, but with NEO Surveyor, they can look much, much closer to the sun than anything in the ground can do. And as Amy noted, the fact that we can now detect them in infrared means we can do a much better job. We're not relying on sunlight kind of reflecting off them. We are actually looking at the heat signatures of them. And so we'll do a much, much better job and much quicker of identifying a lot more of these asteroids, giving us more time. But if they come directly from the sun, we still cannot see them.
Thank you. Unfortunately, my time has expired. I wouldn't be surprised if you get back into this, but let me, of course, allow our ranking member, Ms. Fushi, for her 5 minutes. You're recognized.
Thank you, Mr. Chairman. Dr. Fox, there are many questions I could ask about NASA's important responsibilities regarding NEOs and planetary defense. I'm more concerned, however, with the actions being taken by NASA today. To that end, Dr. Fox, did you direct or approve the cancellation of the NASA Support Services contract and task orders for the U.S. Global Change Research Program?
I'm going to take that for the record so I can get you an answer on exactly how that happened.
Well, do you agree with NASA's contract cancellations for USGCRP, which supports federal agency efforts related to the National Climate Assessment and the 7th International Panel on Climate Change?
As a member of the executive branch, we follow all rules, all direction given to us in executive orders.
Dr. Payne and Dr. Mainzer, your work takes place within research institutions and universities which have been under assault by this administration's actions. Can you share with us the impacts on your institution, students, and research from the administration's efforts to freeze and defund science, including the drastic reductions being proposed for federally supported research and development? And how are these actions, how do they affect your work on NEOs and planetary defense?
Okay, thank you for the question. So I'll just tell a personal story here. As a graduate student, I was funded by the National Science Foundation Graduate Research Fellowship and NASA's Graduate Fellowship as well. I was trained and did my PhD work at UCLA, where I learned how to build space telescopes because UCLA had a contract from NASA to build a mission for NASA. And so I was part of that, and that's how I got my training. It really does take decades to train scientists like me so that we're capable of executing a mission like the NEO Surveyor mission. And it's an important part of just how we're able to do these things. We really do have to have the investment and the time that it takes to learn the science to be able to do it well. So from my perspective, I would say investing in the world's in the world's scientists is in the United States is really important. I mean, basically, it takes a long time to develop scientists, and the U.S. has consistently invested in science and technology since the end of World War II, and I think it's really made the United States the envy of the world in terms of its capabilities. So I'm very grateful to have had the opportunities to do these things and to hopefully serve our country by building NEO Surveyor. Thank you.
Dr. Payne?
So currently the Minor Planet Center's funding via the Smithsonian is unaffected, and so we've been able to continue on with our work unaltered at present. So at the moment, things are fine.
Thank you. Last year, I had the privilege of serving on the bipartisan AI task force, so I appreciate the opportunities and challenges related to AI. To that end, how can AI and machine learning be used to enable NEO detection and planetary defense? And what are the potential advantages of using those tools? And I'll ask that question of both of you.
Yeah, thank you for the question. So the work that the Minor Planet Center has been doing in this area is to try and use AI techniques to leverage the vast amount of data that we already have on NEOs, asteroids, use that as a training set to help these AI models understand what does an asteroid look like that's harmful versus one that's harmless. And so once one's trained them, you can then use them to try and look at the data that's flowing into us to very rapidly and accurately pick out the NEOs from the data flow that's coming in. And so that's what our current work is doing, and we want to continue that work to build on that so that we can try and most accurately process the NEO surveyor data when that is presented to us.
And on the detection side, we are working on developing our image recognition tools that will help scientists to basically quickly and easily discern legitimate detections of asteroids from noise. So essentially, it's an assistance tool that we can use to help better interpret and more quickly sift out the important real detections from things that are just noise or background objects.
And finally, what resources, including funding, are needed to fully leverage AI and machine learning tools for these purposes?
Adequate funding is certainly a major thing. Also making sure that we have the best high-end computing facilities, which we do at Ames Research Center, and really leveraging the knowledge of the NASA community through the universities, through our other partners, and the great work that's done. I'll just highlight the great work that's done at ATAP. I know I'm out of time, but it's so critical to actually be able to tell us about the impact of the asteroids. Finding them and characterizing them is one piece. What we really care about is what it's going to do when it arrives.
Thank you.
Thank you.
That's my time. I yield back.
Thank you. And now we recognize our chairman, Dr. Babbitt from Texas, for his questions. I recognize Mr. Chairman.
Thank you very much. Ground-based radar observations are a critical tool for tracking and characterizing NEOs. These observations allow NASA to refine NEO orbits and assess the risk of future Earth impacts. The Arecibo Observatory was an important radar astronomy asset for NEO tracking and characterization until it collapsed in 2020. Dr. Fox, in response to letters the committee sent to NASA after the Arecibo collapse and NEO surveyor delays, NASA indicated that it was initiating a study along with the National Science Foundation and the Space Force to evaluate the requirements and potential capabilities for a national deep space radar asset. Was that study completed, and if so, can you share it with the committee?
Yes, as you know, NASA doesn't develop ground-based facilities on our own, but as you note, in 2023, we did join NSF and other representatives in this sort of cross-disciplinary deep space radar needs study, and we looked at whether a coordinated development of future deep space radar facilities should be further explored. We of course will follow any sort of guidance that's in the President's budget request and any congressional direction regarding the FY 2026 appropriation. And I will be happy to go back and see if we can send you that report.
Yes, ma'am, that would be great. Also, the asteroid Apophis is expected to fly by Earth in 2029, and it will be the closest asteroid of its size in recorded history, coming in between the Earth and the Moon. NASA announced that it was extending the OSIRIS-REx mission to study Apophis, renaming the mission OSIRIS-APEX. This mission will only rendezvous with Apophis after the asteroid passes Earth. And Dr. Fox, is NASA exploring future planetary defense missions after NEO Surveyor and DART, such as a rapid, low-cost mission to investigate Apophis before the Earth flyby?
That's a great question. So I've got two answers for that, actually. One, we did do a study. We looked at a possibility of partnering with sort of non-traditional partners to be able to do that. We didn't find a viable path forward without significant budget input, budget from us that we actually didn't have. But I will note that actually APEX will start taking images of Apophis about 2 weeks before it actually does that closest approach. And so then it will over 2 months catch up with that asteroid. So we will have, even though they're going to be low resolution images, we're going to have some really nice images of like how the light and the brightness changes, which will give us a lot of information on how that asteroid change as it comes within, in fact, within geosynchronous orbit. It's really close. You'll be able to see it. I'm very excited.
Excellent. I am too. Don't want it to get too close, though. Despite strong support from the scientific community for the mission, the Biden administration's FY23 budget request included only $39.9 million for NEO Surveyor, a significant decrease from the $174.2 million in the FY22 budget request. Further, despite NASA receiving $143 million in appropriated funds for the mission in 2022, NASA's 2022 spending plan redirected $33 million away from NEO Surveyor to other projects. Because of this, the launch date for NEO Surveyor slipped from 26 to no later than 2028, and the estimated mission cost has increased by over $1 billion. Dr. Mainzer, if NASA did not reduce this funding, could NEO Surveyor be ready earlier? And what impact would an earlier launch date have on a survey progress?
Well, I will say that, yes, if we had received the funding, I think we probably would have launched earlier. But Dr. Fox can speak in more detail to NASA's budget profile there. But it's certainly true. The sooner we get on the sky, the sooner we can start finding asteroids.
Amen. Okay, and lastly, the George E. Brown Near-Earth Object Survey Act directed NASA to detect, track, catalog, and characterize NEOs larger than 140 meters in diameter, with the goal of discovering 90% of the estimated population by the year 2020. And despite this direction from Congress, the survey has only identified 44% so far. NEOs under 140 meters are also capable of causing severe damage, however. And Dr. Mainzer, again, should NASA have a more aggressive goal for identifying NEOs under 140 meters, given the potential danger they pose?
Thank you for the question. That is a very interesting idea. I mean, basically, yes, anything, as we saw here, anything above about 20 meters or so in diameter will probably make it through the atmosphere and can cause ground damage that's pretty severe. Like you said, Canyon Diablo here, this one was about 50 meters across, and this produced a mile-wide crater. So we know that that size threshold of somewhere between 20 to 50 meters is an object large enough to make it through the ground, through the atmosphere and create a crater. So that's probably the size and up worth paying attention to. With NEO Surveyor, we will expect to, over 10 years of surveying, get to that 90% mark for the 140-meter and larger objects. We will still see many, many objects. In fact, the vast majority of the things we will see are smaller than this. And I would expect that after about 10 years, we would see roughly half of the 50-meter and larger objects that we would call potentially hazardous in terms of their orbits.
Great. Thank you, ma'am. I yield back, Mr. Chairman.
Thank you, Mr. Chairman. I now recognize the ranking member of the full committee, Congresswoman Lofgren from California, for her 5 minutes. You're recognized.
Well, thank you, Mr. Chairman. Before asking my questions, I would like to recognize someone who's here today, NASA's former chief technologist, A.C. Charania, who is in the audience. He was riffed from NASA, and I'm sad to say that NASA has lost his expertise. I'd like to follow up, Dr. Payne. Could you please explain how the data processing and modeling by the Minor Planet Center is then used by the teams at Ames and JPL to assess the threat of a potential NEO impact?
Sure, thank you for the question. The approximate sort of process is that observatories around the world submit observations to the Minor Planet Center. We validate them, check that they seem to be correct. We incorporate them into our data set, and that data roughly involves fitting an orbit to the object as best we can. More data comes in, we get better and better orbits. That data is then freely published for anyone around the world to use, including groups such as the CNEOS group at JPL. And they will then take that, those observations and those orbital data, and they do refined calculations of the expected probability of impact, the expected date of impact, and the expected path or location of impact.
Thank you. Dr. Fox, you mentioned the NASA Ames role on this. Could you tell us what we would lose if Ames weren't there to do this work?
We would say if Ames were no longer able to do the assessment, then what we would lose is really the ability to give our sort of early expert advice to FEMA, which of course is then responsible for deciding whether perimeter is what the response is to protect as much human life as possible. That's really what we rely on the expertise for Ames to do.
Democrats on the committee have sent numerous letters to NASA asking for a whole variety of things, some directed to you, many not. We haven't received answers to any of them, I'm sad to say. So I'd like to ask you a couple of questions that I believe your lead, the NASA Science Mission Directorate. So I'd like to ask you just a few questions about that. NASA's annual omnibus solicitation for research grants, I think it's called ROSES, I believe is 3 months late and counting, and I don't think there's been communication from NASA to the research community on this issue since March of this year. I'd like to know whether you made a decision to pause or halt the issuance of new research grants, or whether you were directed by any DOGE-affiliated person, or whether that was recommended to you by a DOGE affiliated person to pause or halt the research grants. I'd like to know why NASA has not issued ROSES 25 omnibus solicitation. And finally, NASA has had an enacted fiscal year 2025 appropriation for more than 2 months. Is NASA spending the money it's actually been appropriated for 2025?
Thank you so much for the question. Yes, we are spending our FY25 money in accordance with law. And as with the ROSES, I made the decision to pause the ROSES. I did want to actually await the skinny budget. The last thing I want to do is put out a solicitation and have a lot of people spend a lot of time actually writing proposals if it's something that we would have to withdraw. We're in the process of looking at actually making final edits to ROSES to put it in line with the presidential priorities, as well as what we're seeing in the president's budget for 26, as well as the continuing resolution for 25. We are finishing that up. My intention is to get that through final approval and out hopefully as early as the end of this month.
Dr. Mainzer, how will the infrared observations from the NEO survey mission, which you lead, how is that going to really improve our ability to model the impacts? Help us understand that.
It'll benefit us in a couple of ways. It'll help us find the objects, including the dark fraction of the population, which we think is sort of roughly 35 to 40% or so of the population. And it will also help us measure the sizes, because we can quickly convert the infrared fluxes into a diameter as soon as we get an orbit from the Minor Planet Center. That actually tells us a lot about how potentially hazardous something is, just because that's such an important component to the impact energy.
Very interesting. Thank you, Mr. Chairman. I yield back.
Thank you. I now recognize the congressman from Utah, Mr. Kennedy, for 5 minutes.
Thank you, Chairman Herodopoulos and Ranking Member Fauci, for holding today's hearing on NASA's planetary defense. Thanks to the witnesses for coming. Dr. Fox, you're a perpetual witness. Thank you for continuing to return, in spite of the hard questions that we sometimes ask. As evidenced by the 2024 YR4 incident, we can't defend our planet from things we don't see coming. These collision events have the potential to threaten life, cause devastating destruction to critical infrastructure, and cost millions of dollars. For all of these reasons and more, the work of NASA, the Minor Planet Center, and the International Asteroid Warning Network and other partners is very important. It's vital that we as Congress support the work that you and others are doing. I'll start with Dr. Payne. I was very interested in your testimony. You said 2,500, I think you said 2,500 employees in 80 countries are involved in this very integrated network throughout the world. And given the global nature of this threat, the planetary defense strategy really does call for coordination amongst all of those entities. Could you speak, Dr. Payne, to how your respective organizations help share data for newly discovered NEOs and how we coordinate a rapid response as these worldwide threats are recognized and need to be mitigated?
Thank you for the question. So the observatories that send data to us are a mixture of amateur and professional, spread all around the world. And we initially validate them to make sure that they sort of meet performance standards, and then after that, they are free to submit data to us. So anyone from around the world can do so. Once they send that data into us, the Minor Planet Center validates it and ascertains whether or not it seems to be something that's an NEO or potentially hazardous one. We publish that data on our NEO confirmation page. There's a data set that then anyone around the world can interact with. They can use that for free, and they can then plan their own observations to try and contribute to these global efforts to refine the orbit, get better data that then comes back to the Minor Planet Center, and our data set grows and is made available to centers such as the JPL, CNEO's group, who can do the detailed orbital calculations. But there are other equivalents around the world, say ESA funded, that also contribute.
All hands on deck. I love it. Thank you very much for bringing that. It's a nonpartisan issue and a non-country-based issue. It's a worldwide issue, and it's really good to see us working together on that. Dr. Fox, I was interested in pointing out the asteroid Apophis will make a close flyby to Earth in 2029, as we've talked about. Part of NASA's planned observational campaign for Apophis includes repurposing the OSIRIS-REx spacecraft to conduct post-flyby analysis of the asteroid. During the original development of OSIRIS-REx, the Space Dynamics Laboratory at Utah State University, which I'm proud to have in my home state, provided detector assemblies for the spacecraft suite of 3 cameras. Can you expand on NASA's plans to utilize OSIRIS-REx for the Apophis close approach?
Yeah, I'd love to. And they're wonderful cameras, thank you.
You're welcome. I didn't have anything to do with them, but Utah State University worked hard on them.
Yeah, I mean, as I noted, I actually hadn't realized that we could start observing it 2 weeks before that close flyby. I really thought we were going to catch up with it and just be able to do that close analysis. So it's going to give us a long baseline over the 2 months using actually those cameras to be able to really start characterizing. It's going to be small, it's going to be kind of fuzzy at first, but you can do a lot with image processing, and we'll pull out the information on that image. And then we'll look at sort of how the brightness changes as it does that close flyby. And so it's really exciting to be able to have this opportunity. And it's designated 2029 as the International Year of the Asteroid. It was actually just kicked off last week in South Africa. And it's actually a great opportunity to educate everyone into, what asteroids are, why we care about them, and, why the actual threat to us is pretty small, but very, very significant.
Excellent. 2029, we can all look forward to that. There's a few election cycles between now and then. That's all we think about up here, it seems. But I'll finish with a question for Dr. Mainzer. Utah State University is home to the Space Dynamics Laboratory, or SDL, which has a rich history of supporting planetary defense efforts. The laboratory built, tested, and provided mission support for the NEO-WISE spacecraft, which until its recent retirement provided valuable NEO characterization capabilities. More recently, SDL has been supporting the development of NEO Surveyor. This includes providing expertise on space-based infrared sensors, since the Surveyor's main instrument is a telescope that operates in 2 infrared wavelengths. What advantages, if any, do space-based NEO detection systems have compared to ground-based observatories?
Space-based observatories, excuse me, like NEO Surveyor, are complementary to the ground-based visible telescopes that we have. Our telescope in space will be able to point closer to the sun because we have a big tall sunshade on it. And as you've noted, we have infrared sensors that can allow us to measure the heat coming off of the object. So that gives us a very good complementary view of the objects compared to what we can observe on the ground with visible telescopes. And SDL has been a wonderful partner in both NEO-WISE and NEO Surveyor.
Thank you for pointing that out. I was hoping you'd bring that up. Thank you, Mr. Chair. I yield back.
Thank you. I now recognize Representative from New York, Ms. Gillen, for 5 minutes. Recognized.
Thank you. Thank you, Chairman. Thank you, Ranking Member Fushi, and thank you to all of our witnesses. While the chances, I understand, are statistically small, the impact of an asteroid collision with the Earth would be devastating. We've all seen the Hollywood versions, and based on the clip you showed this morning, it looks like they're not so far off from what would be the real accurate impact. So for that reason, Congress has directed NASA to survey all the near-Earth objects greater than 140 meters in diameter to ensure that that does not happen. And I'm glad that my colleagues on both sides of the aisle have voiced their strong support for the funding of NASA's NEO Surveyor mission, a satellite that will complete our survey of near-Earth objects. And Mr. Chairman, I ask unanimous consent to enter into the record a 2022 letter authored by members of the committee in support of the surveyor.
Without objection.
So my first question is for Professor Mainzer. So I'm just wondering, what impact would the skinny budget, $2 billion in cuts to NASA science have on the launch of the surveyor?
Yeah, thank you for the question. So we have not seen the details of the budget yet, and I'll defer to Dr. Fox here, who probably knows more than I do. From my perspective, we do not know the impact yet.
Okay.
Thanks.
Welcome back, Dr. Fox. Nice to see you again. If you would answer the question, that would be helpful. Thank you.
Yeah, we are looking forward to receiving the full President's budget request. As you note, we've only seen the skinny budget. There's only 2 missions that are highlighted in that. So we are awaiting the arrival. We've had, as I noted, no direction to take any action based on the 26 skinny budget. NEO Surveyor is well funded. I'm really pleased to say that they are on schedule. They are within the budget that we confirmed them when they had their confirmation review in 2022. And despite the devastating fires that happened in California, the amazing team at JPL actually only lost not really just about a month of schedule due to that. So that does put the telescope on the critical path, but something has to be on the critical path. You know, you're the last child out of the house dictates what time you get to school. And so something has to be on the critical path, and it just happens to be the telescope. But everything really looking great. And if you have a chance to visit JPL, I know they'd love to show you the telescope. I had the privilege of seeing it just a few weeks ago.
Oh, I would very much enjoy that. So what else, are there other things that we can do to ensure that NEO Surveyor stays on track for a 2028 launch?
We totally appreciate the support. I mean, you noted this bipartisan support. You know, if we can't all unite on a large chunk of rock hurtling towards the planet, what are we going to unite on? You know, and I really do appreciate the bipartisan support that we get. I actually appreciate the bipartisan support that we get for NASA science. I'd like to thank each and every one of you for that. You recognize the importance of what we do and the inspiration that we provide. And so really keeping up the support and helping us as we talk about the importance of planetary defense. You know, and again, just really appreciate your support.
Dr. Payne, could you elaborate a little bit further on partnership and how AI technology can help you in your mission?
One of the sort of partnerships that I've been trying to sort of leverage and will try to leverage over the coming years is with the Smithsonian's Astro AI Institute, where there's people in-house with that expertise and sort of the knowledge of how to develop and train these AI models. And the Minor Planet Center has a huge data set from the data that's been sent to us over the decades and centuries. So there's an exquisite data set that can be used for training and developing these models for different aspects of object identification, data processing, etc. And so it's those aspects that I'd expect to work on over the next couple of years related to that.
Thank you, Dr. Payne. And again, Dr. Fox, you mentioned earlier in your testimony that now we are not concerned about YR4 having impact on Earth, but you did mention that the moon is not out of danger. Do we need to be concerned about an impact on the moon?
I can happily report that if it is only a 1% chance of impacting the moon, and obviously as we get more observations in 2028, we'll be able to really refine that. But if it did impact the moon, it would not change the moon's orbit.
Okay, thank you. I yield back.
Thank you. I now recognize the representative from California, Mr. Whitesides. You're recognized for 5 minutes.
Thank you, Mr. Chair. I want to start by thanking you and the ranking member for holding this hearing. This study of asteroids and the potential threat to Earth is of high importance to the United States and to humanity at large. When I served as Chief of Staff of NASA over a decade ago, I strongly advocated for greater funds for research and missions in this subject area. The U.S. is the unquestioned leader in asteroid studies, and with the success of the DART mission, is also the only country that has demonstrated the ability to modify the orbit of an asteroid body. I'm also super proud to have many JPL employees who live in my district who are now working on Dr. Mainzer's mission. One of our witnesses represents the Smithsonian's Minor Planet Center, which in my opinion is one of the best investments that the federal government makes. It is truly a world-leading center of monitoring asteroids, and its budget of whatever it is, $3 or $4 million must be protected. I think, in fact, a very reasonable question is whether NASA should, in fact, be spending more money on asteroid monitoring and defense, given the catastrophic risk to our country and civilization. My estimate is that over the past decade, the per-year average spend on asteroid research and defense at NASA is on the order of 1% of the agency's budget. So I think that might be a conversation that we can have over the coming months. However, as several members have mentioned already, our leadership in this area, like so many areas of space and earth science, are under threat now from the proposed cuts to NASA's budget, as well as the budgets of other science agencies like NOAA, NIH, NSF, and NIST. We must continue to fight this budget and make our voices heard on why such cuts threaten our families' health, our national security, and our future economic prosperity. I'm encouraged by the words of members of both parties on this committee that such cuts should receive active debate in Congress per our constitutional responsibilities. So I'm just going to dive into a couple quick questions. So Dr. Fox, I have a few questions about scientific integrity and public access to data, publications, and other end products of federal research funding, which are governed by numerous laws and regulations, including NASA's own Organic Act, which directs the agency to, quote, provide for the widest practicable and appropriate dissemination of information concerning its activities and the results thereof, end quote, and the Evidence-Based Policymaking Act. There have been reports at federal science agencies of archives being taken down and of challenges with the renewal of contracts to store data. I am deeply concerned, whether through intentional action or frankly incompetence, irreplaceable digital archives that store government-funded science data will be lost or corrupted. What is NASA doing to make sure that this does not occur inside the agency, and what can you do to support science archives in other agencies, potentially like NOAA? Maybe, 30 seconds to a minute.
Thank you so much for the question. Obviously, scientific integrity is part of what we do. It's the responsibility of every one of our scientists. For the data storage, we take very seriously our data archiving. We've put a lot of effort in the last few years in modernizing our data archiving to ensure that the data are open and accessible for everybody. We continue to do that. We've had no change in direction for putting that emphasis onto preserving every bit of our data, and we will continue to do that.
Thank you. Will you commit to informing this committee in advance if you are directed to do anything that would lead to the loss of government science data archives, whether climate data or otherwise?
If we receive any direction, that would be part of an executive order, and that I assume will be available to everybody.
Thank you. Dr. Fox, the Trump administration recently released the top-line numbers for the FY26 budget request, and the president is proposing to cut the NASA science budget, as discussed, by nearly in half. In your testimony before the subcommittee last month, you stated that you could not know the impact of a 50% cut because you hadn't seen the budget yet. And I think you've testified earlier today that you haven't seen the detailed budget, although we have, seen a specific. Can you briefly just tell us what the impacts at a top line would be of a 50% cut? I mean, you run the Directorate. You know at a top line what the impact on the number of missions or other issues would be. Can you just sort of walk us through that at a top level?
Yes. I mean, as you know, the skinny budget, we do have our top line number. Earth science is specifically called out, so we do have the Earth science number. We have not seen any details on the missions or any direction on missions other than the Mars Sample Return Program and the Landsat Next, which is joint with USGS. We await the full president's budget so we can see the priorities and the direction on which missions may be supported or not supported. And I will be happy to come back and brief you when we have that information.
Thank you. Mr. Chairman, I yield back.
Thank you. I will now recognize a representative from Oregon, Ms. Salinas, for 5 minutes. You're recognized.
Thank you, Chair Herodopoulos and Ranking Member Fushi, and thank you to our witnesses for being here today. This administration's efforts to undermine NSF, NOAA, NASA, and other research agencies are fundamentally attacks on our national security. They threaten, certainly, ongoing work in Oregon to better understand, predict, and effectively respond to earthquakes, tsunamis, wildfires, and yes, even asteroids. As we've heard in this hearing today, some of these disasters may be rare, but the risk they pose is real. If government fails to support this science, we will be failing at our most basic obligation as members of Congress to protect the health, safety, and security of our constituents. Professor Mainzer, in your experience, how do a variety of funding streams work together to support institutions, labs, and researchers, and to what extent does your institution rely on a combination of support from NASA, NSF, and other science agencies?
Well, I can't speak for the university I work for as a whole, but I can definitely say that, just in general, as a scientist, it's important to have sustained funding for these topics because, as I mentioned earlier, it really does take decades to train scientists like me, and to keep the U.S. in its current leadership position in science, I think continued investment is incredibly important for universities, for federal labs, national labs, as well as companies. Just basic research, it really takes time sometimes to pay off in terms of tangible products in our everyday life. But it's so incredibly important, and the U.S. is unquestionably a leader in science and technology, and we want to stay that way.
Thank you. Dr. Fox, how are you coordinating with partners across federal agencies, federal science agencies, to ensure that we will have the capacity at research institutions and in the scientific workforce to conduct robust NEO research should your agency see such drastic funding cuts as we've discussed today?
Yeah, as we noted, NASA really leads at not just the U.S. but leads the world in this particular field of planetary defense. We will continue to work across government, and we will work across with our international partners, using every resource available to us to be able to continue the U.S. leadership of planetary defense.
And are other countries ready and available to step up should we have a drastic funding cut?
We've had no discussions about particular funding levels. We are, as we noted, this is a global problem. Amy said in the video, it doesn't care about country borders, and so we through the International Asteroid Warning Network, which NASA put together, also Same Page, which I can't remember what Space something advisory group, sorry, but Space Planning, I think it is. We'll continue to work with them, and we use everything available, and whatever funding that we have for planetary defense, we always put to great use.
Thank you. The administration has directed science agencies to cancel existing grant fundings, important STEM education activities, on the grounds that these promote diversity, equity, and inclusion. These included an NSF grant at the University of Oregon, helping teachers across the country to help girls access STEM fields. Dr. Payne and Professor Mainzer, in your experience, does talent in your field come from any particular background, and have you seen value in programs that help to expand STEM opportunities to folks from non-traditional backgrounds, including those from rural areas?
In my experience, science benefits from having the best available talent across all different backgrounds. We work with people and scientists all over the world, and on this particular problem, it is global and international, so we really benefit from everybody's contributions. It's just so important that science be available and accessible to everybody. So from my standpoint, I think the most important thing is really trying to expand education and opportunities to keep that U.S. leadership. That means we really do have to draw on talent from everybody, everywhere. It's important. It keeps the U.S. in the lead.
Thank you. Dr. Payne, would you like to comment?
I would just echo pretty much everything that Professor Mainzer there said, and possibly, as Professor Mainzer is alluding to, I've benefited from the ability to come here freely and to be able to contribute to this global effort, so I'm very grateful for that.
Thank you. And with just a few seconds left, Dr. Fox, how have you responded to the White House's DEI and directives in your work, and how will you ensure that you support talent everywhere, despite efforts to rein in support for underrepresented Americans?
Yeah, thank you for the question. We obviously follow all the guidance in the executive orders and have done so. but we continue to have our solicitations. We noted we're going to put the ROSA solicitations out. They are open to everybody, and we look forward to getting great proposals in and picking the best science and the best technology to move forward with.
Thank you. My time has expired. I yield back.
Thank you. I want to thank each of the witnesses today for the thoughtful comments and valuable testimony. I also want to thank the members for their wonderful questions. The record will remain open for 10 days for additional comments and written questions from the members. And with that, this hearing is adjourned.